Hi class, today we're going to be discussing soluble and insoluble salts. First off, I have a cat, my old cat is sleeping next to me and she snores, so if you hear a weird sound in the background, like that, that is her sleeping. Signs of a chemical reaction has occurred. So the first thing we need to know is we look for signs of a chemical reaction. Today we're going to be focusing on the formation of a precipitate. When two liquids react and they do not look the way they did before you added them together. So this can mean that you can have small, tiny particles. That's still considered a precipitate because they weren't there before, all the way to something that's rock solid. So double displacement reactions is a key thing here for this lab. There are three types of double displacement or double replacement reactions. The first one is the one we're working on, is precipitation reactions. There's also neutralization reactions with an acid and a base, which produces water. And then gas evolving reactions, which if you take a step here, that's a chemical sign when you have bubbles that are being emitted from a reaction. It's usually oxygen gas or hydrogen gas. So here, think of people dancing on the dance floor, two couples, and they switch partners. That's all this is. It's very simple. We switch them out. If you have a problem learning how to switch them out, make sure you have them in ionic form, cation and anion, so you can easily transfer them over to the new partner. How do we know if a solid precipitate has been produced? We look at a solubility chart. That is going to tell us what we need to know, and we'll cover that. But what if there is not anything happens? Then there's two things, and depending on what's being asked of you, you could either write no reaction here, or you would put aqueous with every single thing, which means that all the ions are swimming in aqueous solution. But if there is a solid, then you would have to make sure and indicate it with the physical state of an S. That's why we need the physical states. They really do tell us a lot about what's happening. So there's tons of solubility charts online, and there's one in your book. This is the one that I use. It's a little different. Some might think it's more complicated, but for me, it has everything. Not all solubility charts have all of these compounds listed, and I like this one because it does. So there's two different types. There's soluble ions that are soluble when they come together with other elements, and then there's insoluble. The first one, anything listed here is soluble. It's automatically soluble. So if there's an exception, which means it'll form a solid, they will be listed here. Group 1 ions, anything that's attached to a group 1 ion is always going to be in aqueous form with whatever it's attached to. There's no exceptions. Same as ammonia, same as nitrate, acetate, hydrogen carbonate, chlorate. And when you get to the halides, we have chloride, bromide, and iodide. They are in aqueous solution. They stay in ionic form, except for when they come into contact with silver, lead, or mercury. Then they become solid. And the same for sulfates. There's exceptions for sulfates. Over here is insoluble. This means these automatically form solids, except for when they come into contact with any of these. So for instance, carbonates automatically form solids, except for if it comes into contact with group 1 or ammonia, which is already listed over here. So then it will be in aqueous solution. It's not a solid. And the same goes down here. Chromate is automatically a solid unless it comes into contact with group 1, calcium, magnesium, or ammonium. Then it stays in ionic form and it would be aqueous. This is the solubility chart listed in your PDF. I'm not a fan of this. It looks more simple. However, I have a problem with something here. So if you see halides here, halides are soluble, except for silver, mercury, and lead, which matches this one. Underneath it is sulfates, which when combined with silver, calcium, strontium, barium, or lead, these are the exceptions. When you look at it here, which is also sulfates, calcium and strontium, is that listed with the halides or is it listed with the sulfates? If you didn't know, automatically you would probably assume that it's with the halides, except for there's a comma going down with these ones. But it should be lower to strongly indicate that these here are for this one and not calcium and strontium are not for halides. So I just don't like that one little thing that could actually get you wrong answers if you weren't paying attention to that and you didn't know. So my suggestion is use something like this. I have put this on a PDF in Canvas, or use what is in your book. I don't like that this is kind of ambiguous with some of them, and if you're not, I mean, the rest of them seem okay, but just one mistake on here makes me not want to suggest that you use it. Double displacement reactions. When a yellow aqueous solution of potassium chromate is added to a colorless aqueous solution of silver nitrate, a red precipitate, PPT is short abbreviation for precipitate, of silver chromate is formed. So now if we look at this, this already has all the physical states on it. And you can tell it's aqueous, aqueous, they come together, a solid is formed, and then the remaining ions stay in aqueous solution. But if you had to balance this and put this together based on this wording, then you would actually need to know if a chemical reaction occurred. So I pulled this from the previous, not this slide, but this slide, so you can see how this is read. So we have silver nitrate, nitrates, no exceptions, all soluble. That means that anything that comes into contact with nitrate is aqueous. It's going to stay in aqueous ionic form. So the nitrate on here is aqueous, and whatever is on this side is also going to be aqueous. Now we have chromate. Chromate is an insoluble, so it is in my second column over here. Now it has exceptions, group 1 ions, calcium, magnesium, and ammonia. This means that it's insoluble except for when it comes into contact with these. So it has silver. Silver is not one of the exceptions that would allow it to be soluble, so it's going to be a solid. If one doesn't show up, whatever it's attached to will definitely be on the solubility chart. So let's take a look. Complete and balance the following displacement reaction. Use the chart. So if you don't know how to read this, I kind of broke it down a little bit easier. So group 1, this is sodium chloride. Group 1, there are no exceptions. So this is going to be AQ. Doesn't even matter what the second half is because it's no exceptions. But let's say you didn't want to look, whatever, don't like sodium, don't want to look it up. You have halide. So we can look at the halides. It is not silver, not lead, not mercury. So this is going to be aqueous. So now we go to silver nitrate. Nitrates are listed here. There are no exceptions for the soluble, which is listed here. So whatever it's attached to is also going to be in ionic form. No solid's going to be formed. However, so what you see here is that sodium and nitrate are going to join, and the two inside are going to join. So silver chloride. So we look back down to the halides. Silver is an exception. So silver chloride is going to create a solid, but sodium and nitrate both are listed under no exception. So that's going to be an aqueous. So we can look here, and that's exactly what happens. Silver chloride is a solid. Sodium nitrate is aqueous. You're going to need to look at a solubility chart and know how to read it. And if one doesn't show up, whatever it's attached to will be on there. What happens when no precipitate occurs? So here is a reaction that has no reaction. They are just all ions that will end up forming, swimming around in a solution. How do I know that? Well, let's get sodium. Sodium, again, we already know it's listed. There's anything attached is going to be aqueous. Here is another group 1. So anything attached to it is also going to be aqueous, but we also look at halides, and potassium is not part of the exceptions. Sodium again, potassium, but we could look at sulfates. Sulfates one we haven't looked at. Sulfates are listed here, and only these are solids. So that means that everything here is listed as aqueous. So that's where, depending on what is being asked of you in the assignment, you may still need to balance the equation and complete it, but put the physical states, and this pretty much means aqueous all the way across. Nothing happened. There was no chemical reaction that occurred here. All right, so let's get to the procedure of what this lab is about. We do this lab or something similar to it, and it's actually a good lab in person. So it's disappointing that we're not in enough to do this, and it's an easy lab. For the most part, it's easy. It's observations. You're observing if a reaction occurred by looking for a precipitate. Did something change? What it looked like before you joined it with another solution? Does it look that same way after? And that's what you're comparing, and then some problem balancing equations, but it's not really a difficult lab. So here you're going to get a spot plate. So I'm going to show you what a spot plate is. This is a spot plate. And usually the nice thing is most of these are done in pairs. Where the labs at Citrus, you do all these experiments alone. Everybody has their own experiments and data and stuff. This is a lab that usually is done in pairs. So this is a spot plate, and it's palm size, and it takes about, I think, maybe 2 mils of, it's a very small amount that it can hold, but you can do a lot of observations with this by adding a lot of solutions and then seeing if a chemical reaction occurs on a very small amount, but you can still see it. Now, these are the droppers, so let me go on and I can explain why those bottles are on here. So you get a spot plate, and you're going to set it up. So you have to organize how you're going to add it. you're going to have a drop. You're going to have all solutions used in this experiment are 0.1 molar concentration. So that means all of these here are 0.1 molar concentrations, as well as these. You're going to have a bottle. Each bottle is 1, 2, 3, 4, 5, 6. There would be 6 bottles, and they would all have these anions in the listed on it. But it says here the chemicals include sodium salts. What this means that this is sodium carbonate, sodium chloride, sodium sulfide, sodium nitrate, sodium phosphate, and sodium sulfate. That's what would be written on the bottle. And you would add these to your spot plate. And how you do it is that there's a dropper in there like this. You can't really see it that well. And you add it without touching the solution, without touching the sides, so it doesn't create any impurities on it and give you false positives and false results. And then you put it back, and the same person does the same thing. Now, the second part is that you're going to have nitrate salts for cations. So this is anions, this is cations. So this is potassium nitrate, calcium nitrate, barium nitrate, aluminum nitrate, and so forth. Now, what you're going to do is you're going to mix all these together. So you're going to take potassium and you're going to add a few drops to carbonate. You're going to take potassium, you're going to add a few drops to chloride, potassium and sulfide, potassium nitrate, and so forth till you get to the end. Then you're going to take calcium and you're going to do the same. Calcium carbonate, calcium chloride, calcium sulfide, calcium nitrate. Then you go to barium and you do it through the whole thing. And then you're going to look to see if color changed and if a precipitate formed. And that can be milky white with tiny, tiny little particles that are float on top to a thick white substance. And I say white, but white is actually not for all of these. Some of them, like the transition metals, give you colors if there's a precipitate formed. The rest of them that are not transition, if they form a precipitate, they form white. So here is a PDF that's taken from, I took this from your PDF. Now, the one thing is that it's listed here is sulfide. Sulfide is not in this lab, and they should update this. It is hydroxide. So I put a big old box around this. And the box is in for both of them. I should have lifted that subscript. Sulfide's been removed, and this is for both of them. Just cross it out and put hydroxide. This is how they list it. This is not, it's not listed exactly like this in the data lab report. But this can definitely help you when you have to enter all this information, because you're going to have to enter for every one of these reactions if something happened in what color. So you're going to look at potassium carbonate, potassium chloride. So for the first one, this is the first half. Now with this one, you're going to need to use a solubility chart for each one of these things. And if a precipitate forms, I have it here, it will be white. They're going to ask you for color, and they're going to ask you if something happened. Any precipitates here on the first one, you have 2 of them. See, this is potassium, this is second spot plate. These are transition metals. The first one, I have it listed, it will be white if a precipitate forms. So you will have to answer that. The second one, we're going to go through. And if nothing forms, you'll be able to answer no reaction on there. But the second one, the second spot plate, has transition metals with the same carbonate, hydroxide. Oops, that's a mistake. This should be here, and then that means the carbonate's chloride. So I accidentally covered over chloride, but you will see it definitely when you do your data report. So move visually, imagine this hydroxide over this one instead, and the chloride's here. You are going to look to do the second half is if you go to sample data, there's sample data right in between quiz and data. You're going to pull this up, and it's a PDF. I also have it attached to the Canvas. First spot plate results. Use the solubility ionic compounds table in the experiment PDF to predict whether a precipitate forms for each combination. You can use the PDF. Just know that little weird inconsistency. Pay attention to it, or use the solubility chart I give you, or use your book one. Google one. You can find them. Second spot plate, I cut it off, but all of these have precipitate. So this weird looking thing is attached in here to compounds that form precipitate. And it shows the color. So for the second one, transition metals, when they form, will form a colorful solid or precipitate. And it's going to ask you for the color, and it's going to ask you for precipitate form or no reaction. And that's what you're going to answer. So you'll have to pull this up to complete the second one. First one, you're going to have to use a solubility chart, sit there and go through each compound. But remember, I told you there's trends. Nitrates, nothing happens with nitrates. So there's a little trend that you can look at. you can pay attention to. If you look here, there's certain ones, if it attached it instantly, there's nothing that happens with some of them. And it makes life easier if you know which ones those are right away. And if as the more you start doing this, believe me, it'll start picking up which ones. So this is the sample data. Now, going back to the problem that I stated about the PDF, I think it's led to a problem of answering a problem correctly on LabFlow. So this is a problem at the end of doing the spot plate. There's a couple questions, and it's all based on looking at a solubility form. This is a problem that is not right, but it's listed as incorrect, so I'm going to give it to you. Based on the solubility observations, which of the following pairs of cations should be distinguished by the addition of sodium chloride to the solutions? What this is trying to say, and I don't think they're doing that great of a job, is that let's say you have sodium chloride, but you're not sure you have sodium chloride in solution. There is a way to test to see if you have sodium chloride. You can look at a solubility chart, look at both cation and anion, and have it react with something that would form a solid. So sodium chloride, sodium automatically doesn't form anything, so you can't use sodium. You're going to have to use another cation to react with chloride. That's what this question is saying. So we go down the halides, and we would either need to use silver, lead, or mercury. That's what the answer I picked, and I got it wrong. It was silver and lead is my answer, and it was wrong. The correct answer is barium and lead, which is nowhere listed in here. But if you go down to the sulfates, which remember overlaps with the PDF, that's how they have it answered. So they're saying barium and lead. So let's take a look at what happens when you add barium and chloride. Barium and chloride is soluble. It's aqueous, so nothing's going to happen with that one. But if you add lead, it makes a solid precipitate. So this is not correct, but they're marking it, so I'm giving you guys this answer to let you get credit, because it's not fair if you were to answer this correctly and get the problem wrong and lose those points. I don't like that. I'm not thrilled with some of the things that they haven't fixed on this lab. But there you go. So I'm giving this to you. Now here's some tips. Read the experiment on the PDF thoroughly. There are questions on the quiz that are based on the reading. So make sure that you've read it enough to be able to at least find it in your reading. Many questions, I mean, this is a solubility lab. That's all it is. Look at the cations, look at the anions. If one's not listed, the other one will be there, or it is considered an exception, either as a solid or as soluble. If you're stuck on questions, like the one I just read that really doesn't make sense, look at what's given to you and then look at a solubility chart. That's usually going to tell you if something's formed or not, enough to get you to look at the answers that are being presented, because a lot of these are multiple choice, and then you can pick the one that you need. Okay, that's it.